Welcome to Math with Faith. We are looking at chapter 2, where we're talking about measurements, and this is lesson 3, arcs and sectors. So in our previous lesson, we looked at the circle, and we said that the area of a circle is pi r squared, and we also said that the circumference or the perimeter of a circle is given by 2 by pi by r or pi by d, right? So arcs and sectors are parts of a circle. So an arc is a piece of its circumference and a sector is a piece of its area, right? So you can see that here in this diagram. This part of the circumference, that's the arc. This piece of this circle, like a pizza slice, is called a sector. So a piece of a circle or a piece of its area is a sector. That looks like a pizza slice. And the circumference, a piece of the circumference is called the arc. So if we can find the circumference of a circle, and we can find the area of a circle, we can also find what piece of that circle will be like. And that's dictated by the angle in this pizza slice, right? Because this part of the circle has an angle theta. And we remember that the total angle in a circle is 360. So if I would just want to know what part of this circle is its arc or its sector, I just have to say, well, the fraction of the circle that I'm looking at is theta out of 360. And then I would multiply it by the circumference to find the length of the arc, or the area of the circle to find the area of a sector. So the piece of the circle that we're looking at, that fraction of the circle, this is theta of 360 of, and remember, of means to multiply, of the total circumference. It's theta out of 360 of the total circumference, which is given by 2 pi r. So the length of an arc is given by theta out of 360 by 2 pi r. And the area of a sector, we're looking at theta, that fraction is theta out of 360 of the area of the circle. So the area of a sector is given by theta over 360 multiplied by pi r squared. So that's how we find the area of an arc, of a sector, and the length of an arc. So let's look at the example. So a circle of radius 8 centimeters is divided into 12 equal sectors. So yeah, it's like a 12-piece pizza, right? So this circle is divided into 12 equal sectors. So the first question is, the first question is, what fraction of the circle is one sector? So if it's divided into 12 equal sectors, one sector will be 1 out of the 12 sectors. So the fraction of the circle that's one sector is 1 out of 12. So the next question is very obvious question. What is the angle at the center of the sector? So remember, the total angle is 360. So this is 1/12 of all, which is 1/12 of 360. Right? So when we divide this by 1, we get 30 degrees. So that is 30 degrees. So if we multiply 30 by 12, we get 360. So each of them has an angle of 30 degrees because it's 1/12. Every one will be 1/12 of the total, which is 360. So therefore now we can find, I'm putting C across here, the length of the arc. And we know that the length of an arc is given by theta out of 360 multiplied by the entire circumference, which is 2 pi r. And look at how theta over 360 is going to come back to be 1/12. Look at this. Theta is 30 out of 360 multiplied by 2 by pi, which we will use as 22/7 by r, as they said, is 8 centimeters, right? And what is 30 out of 360? 3 into 3, 1. 3 into 36, 12. So you see, it is the theta out of 360 is just telling me that that's the fraction of the circle that we are looking at. So it's 1/12 of 2 by pi by 8. So we could do some canceling off here. This could divide by 2, and we get 4. This could be 3. So 4/3 pi. 4/3, and pi is 22/7. Can I reduce anything here? It doesn't seem so. So 88/21 centimeters. And 88/21, 21 by 3 is how many? 1, 3 is 3, 3 2s are 63. And by 4, 1, 4, 8, 4 2s are 8. So it's 4, remainder 4 for 21 centimeters. And of course, that was just trying to work it out without using a calculator. But we could have just used the calculator from all the way here, which is, I'm plugging it in now, 1/12, 1/12 by 2 by pi by 8. And I'm using 22/7 for pi. So 1/12 multiplied by 2 multiplied by, I'm putting 22/7 for pi by 8. So that's 4.19, right? So of course we got the same answer, but just in decimals, right? Centimeters. And last but not least, part D says, what is the area of the sector? So the area of sector, we already know that theta out of 360 is 1/12. So we could calculate it like that, multiplied by pi by r squared. So theta over 360, as we know, is 1/12. Pi is 22/7, which we would use unless otherwise requested. And we know that the r is 8. So let's plug that into our calculator. 1/12 by 22/7 by 8 squared. And we get 16. Then work it out normally here. But if you get this in a multiple choice exam, you don't have your calculators in multiple choice. So you need to know how to calculate without using a calculator. And of course, the units here will be centimeters squared. So always remember your units, guys. So we have 4.19 centimeters and 16.76 centimeters squared. Always remember your units when you are when you have put your answer for your calculation. All right, so that's how we do the area of a sector and the length of an arc in a circle.